Alright guys, last question from this section, 3.5. This one is the last type where it tells you to find the zeros, but it tells you also a hint, one of the complex zeros. It says 1 plus I is a 0. So remember again, using the same theorem, this is really the only theorem we've been using this whole class that's new, the conjugate zero theorem. It means I also know that 1 minus I is a 0 as well. Yeah, the conjugate is a 0. So what we're going to do is we're going to take these two zeros. We're going to use that fact to make a new polynomial and divide the original polynomial by that. The new polynomial that we make is just this guy. It's x minus 1 plus I times x minus 1 minus I. Okay, why did I choose that? Well, I chose that because these are the two zeros, right? So if something is 0, that means x minus that 0 is a factor. So I write these two factors out together. These are the two factors that I know. Then it's going to tell me an overall factor that's a factor of my original polynomial. Okay, I said factor a lot in that last sentence. I hope that made sense to you. So all we're doing is we're taking the zeros, right? We're writing it out as x minus each 0. And we're going to multiply that out and divide the original polynomial by it. The reason why we multiply it out is because as it stands, if I just do one at a time and try to divide by this thing, that's pretty impossible because I have this I in there, right? That throws everything off. But when I multiply these two things together, something magical happens and these i's are going to end up disappearing. Okay, let's see. So this is actually just like one of the questions we did earlier. In fact, almost exactly the same, kind of just by chance. We're going to rewrite this guy without the parentheses. So this is x minus 1 minus I. This is x minus 1 plus I. So you notice again we have a difference of squares sort of hidden here. This is x minus 1 minus I, x minus 1 plus I. You see that? You see that difference of squares? Left side minus, left side plus. So difference of squares means I'm going to end up with x minus 1 squared minus the part that's subtracted and added squared. So x minus 1 squared minus I squared. Right, that simplifies to x squared minus 2x plus 1 minus negative 1, because I squared is just negative 1, right? You see that? Let me keep this in parentheses so we're clear where that came from. This is the x minus 1 squared part here minus I squared part, which changed to negative 1. Alright, I'm going to squeeze in one more line here. I know I don't like to squeeze, but this is not so bad. I have enough space here. X squared minus 2x plus 1 minus negative 1 is actually plus 1. So plus 1 is plus 2, like that. Yeah, so now I'm going to copy that at the top. Actually, I take that back. I'm not going to exactly copy the top. I'm just going to keep this in mind. This is a factor of my original polynomial I found, right? So this is a factor. That means if I divide the original thing by this, then I'll get a new polynomial. And then I can work from there to find the remaining zeros. What is the question asked? Yeah, find the zeros. Yeah. Okay, so let's do that. What I'm going to do is I'm going to take my original polynomial. I'm going to divide by that. So I need to write out that division. This is a long division part, like we did back in section 3.3, I think, 3.3. I'm just copying this down again so that I can have space to write out the division. We're dividing by x squared minus 2x plus 2. X squared minus 2x plus 2. Okay, remember when we do these divisions, long divisions, we want to think of each column as being for its power. So this is a column of x to the fourths, this is a column of x to the thirds, x to the squareds, and regular x's, and then the regular numbers. So my number here, x to the squared, x squared goes into x to the fourth, x squared times. That means I'm going to write my answer here, x squared, right over the x squared column. X squared times x squared is x to the fourth. X squared times negative 2x is negative 2x cubed. X squared times 2 is positive 2x squared. But remember, we're subtracting that whole thing, right? So subtract that whole thing in parentheses, And then we're going to write our answer here. X to the fourth minus x to the fourth. That's just gone. Negative 2x cubed minus a negative 2x cubed. That's actually the same as negative 2x cubed plus 2x cubed. So that guy's gone. Then I have negative x squared minus 2x squared. That is equal to negative 3x squared. Yeah. All right, so now I'm looking, next part is how many times does our polynomial x squared minus 2x plus 2, how many times does the x squared part go into negative 3x squared? And the answer is negative 3 times, right? So that means there's nothing in the x column. The next thing I write should be a negative 3. Right? It just so happened that there's no x cubed part here, so there's no x to write here. I'm looking at how many times does x squared go to negative 3x squared. And that's negative 3, so negative 3 times this guy. I'm sorry, before I do that, I'm going to bring this down. This is plus 6x and minus 6. So now negative 3 times x squared, that's going to be negative 3x squared. Negative 3 times negative 2x is positive 6x. Negative 3 times 2 is negative 6. You see that these actually match up perfectly, which is what I should have expected, because now when I subtract this, it's going to turn out to be 0. Yeah, everything just cancels beautifully. It's beautiful. Let's see, where's my black marker? Cancelled, cancelled, cancelled. So that means I divided perfectly, which I actually expected it to divide perfectly since I found a factor to start with, right? This is a factor of my original polynomial. Right, what does that mean? That means my original polynomial can be written out as this thing times that thing. Okay, I'm going to write that down on the side and erase everything else. Actually, the only thing I really need now is the x squared minus 3 part. So I'll just leave that at the top. X squared minus 3. Let me rewrite that. X squared minus 3. X squared minus 3. So all I need to do now is find the remaining zeros from this piece. I could use the quadratic equation here, or the easier way is just to set that equal to 0. Remember, the quadratic equation is just telling me when that thing is equal to 0 anyway. So to solve this thing, add 3 to both sides. X squared is equal to 3. That means x is equal to plus or minus the square root of 3. So finally, answering my question. What are the zeros? Well, the question started by telling me one of the zeros was 1 plus I, right? We used the conjugate zero theorem to find the second zero, 1 minus I. And just now I found the last two from that remaining polynomial. It's square root of 3 and then negative the square root of 3. So those are the 4 zeros. And my pajama leg is in the screen this whole time. Okay guys, that's it. Let me know if you have questions. As always, I have my same office hours if you guys have further questions, and we'll also go over some of these kinds of ideas on Wednesday's class. All right, peace.